Alrighty, everybody, welcome to exercise 7. This exercise, we're going to be focusing on raster data. Now, the difference between raster and vector data is, vector data, you've got your points, lines, and polygons, and then your raster data, you have more of a grid, and each cell in that grid has some kind of value depicting something. So you may have a raster depicting your elevation. You may have a raster depicting your slope. You may have a raster depicting different land use, in which case a value of 1 might stand for agricultural, whereas a value of 2 might stand for urban. And through these rasters, we're able to, describe some more complicated features than you can with vector data. So to go ahead and start, I'm going to go ahead and create our map. How that gets started, we're going to work on loading our data in here. Add our folder connection to our data. We're going to see here in our data that we have two pairs of, we have 3 pairs of data. So you have your 5 meter data, your half meter data, DEM, and your half meter DSM, but each one comes with a matching hill shade. Now, as a quick reminder, as we load these in, your hill shade doesn't actually store data. What it's storing is color. So a hill shade is added to give some more definition to your eyes, but it doesn't actually have any important values in there. What you're going to see as we add the rest of the hill shades in, if you look over at your table of contents, each of the hill shades range from 0 to 254, and that's these these values describe the color bin that the hill shade is pulling from. So if you have a color value of 0, you're pulling from the darkest of the color bin. This is a value of 254, you're pulling from the lightest of the color bin. So we are going to group our elevation models with our hill shades. And we're going to do that with the hill shade layered underneath to give it the correct look. So I'm going to go ahead really quick, just arrange that. I'm going to start here at the bottom with our 5 meter. I'm going to hold Control and click on our DEM. So now I've selected both the DEM and the hill shade. I'm going to right click, come here to group. I'm going to group that. I'm going to name this layer. You can double click and adjust the name this way, or you can right click, properties, and adjust it here. I'm going to name this 5 meter DEM. I'm going to collapse this and turn this off so that I'm cleaning up my workspace. Going to do the same thing with our half meter DEM. Control, select to group. And I'm going to rename this group half meter DEM. Close that up. And then one more time, Control, select to group. Rename this as half meter DSM. Which is a slightly different thing than our DEM. And then just for my own sake, I'm going to take our places of interest and make our dots a little bit easier to find by making them bright red here in our symbology. And now they'll be a little bit easier to find when we get to them. Okay. So now that everything is named, I'm going to open up our groups again so I can see everything. And I'm going to, as a quick note, we'll stop here Our DSM versus our DEM, you see they're both half meter, but our DEM is going to be our digital elevation model. Our DSM is our digital surface model. So if I turn our DSM on, you'll see that we are looking at tops of buildings and trees versus our DEM, which is we don't get that. And that is because this surface meter is going to be what we call first return from the uh, whatever was used to collect this data. If since it's half meter, it's likely from lidar, though our instructions don't specifically name that. Uh, that means that the laser that the system was using uh, bounced back at whatever it first hit. So it's going to be tops of buildings and trees versus our elevation, where it can be set to report back the bare earth. So it's going to bypass your tree canopy and your houses. Regardless, we're going to come in here to our uh, top layers, so not our hillshade layers, but our DSM, our DEM, our other DEM layer. We're going to come here to raster layer at the top. We're going to adjust the transparency, turn this to 50, so that we can see our hillshade layer through it. And now you see that that hillshade is coming through and giving us a lot of contrast and visibility where we can now see things a little bit clearly, more clearly. So we come here to this one next. Again, raster layer at your top ribbon. And you can also click and drag this, but since we're going for 50 specifically, I'm just going to type 50 in and give it a minute to populate. There we go. As you can see, again, we have a much clearer image, more defined with our hillshade in there. I'm going to turn this on to select this layer and adjust the transparency one more time. Now you can add color to your elevation models if you would like to. I'm going to keep it in grayscale, but you could come here to your symbology and adjust your color scheme to elevation like that. This is not a great choice for your elevation, but so long as you choose a continuous one, you can play around with different elevations to choose. I'm going to keep it in grayscale. But your hillshade should always be in grayscale. Don't ever change this color to something like this. Don't ever do that. You always want to keep your hillshade in grayscale. So now you can take a minute to kind of explore the different areas that you are working with and have available to you and all these different rasters. You can zoom to layer to check out the extent. You can zoom in and see if you recognize any of the buildings. It's up to you to go ahead and check that out. Another thing you can do is come back here to raster layer. And let's say I want to compare this half meter digital surface with our half meter DEM. I'm going to turn everything off but that. I'm going to select this half meter DSM. I can come here and select the swipe tool up at our top ribbon under raster layer and compare. And now you can see that I can drag away the top layer. So we can also put our hillshades back on, and then I can just select this group. As you can see now, I've on our group layer tab here on our top ribbon, I have swipe still selected. Now I can just swipe the whole group away, and we can see the difference between that first return and that bare earth return LiDAR model. So yeah, there are a couple cool things you can do with that. Moving on now, we're going to take a quick look at the important properties you need to know about your raster. So I'm going to come here to our half meter DSM, open up our properties tab. Now it's important to know your raster resolution. So in this case, that's going to be our cell size, which is 0.5. And I also know that our units are meter, which is going to be an extent spatial reference. So now our linear unit is meter. So I know that our resolution is half meter. I can see that our here in our statistics that I have our maximum, minimum, and our mean values that are stored uh, in our raster cells. So we can see our maximum matches our table of contents, our minimum too, and then the mean elevation value for this particular layer is stored there. You can also find your coordinate system here in your spatial reference. So we see it's a projected coordinate system in our UTM zone 12N. And we can come here to our metadata to see some information about it. There's not a whole ton of information here in the metadata. So what you could do is go on to the internet and search up the information that you do have and take a spin around the internet until you can find some more information. It can tell you how old it is and what kind of quality we're working with. But we're going to go ahead and move on. You should now be at a point where you can answer the first 5 questions in your assignment instructions. Your first question is asking you what your highest elevation or your maximum elevation is for your half meter DEM. So this one, your maximum elevation is for that. And you'll want to explore your 5 meter DEM properties to find the information for the unit that this uses, your resolution, which remember your resolution is the length of the side of one of your pixels. So it's going to be here in your raster information. You're asked about the extent in question 4, which you're going to find here. Remember, this is the extent of your layer according to the coordinate system. And your question 5 is your average elevation of this layer, which you're going to find in statistics. Moving on, we're going to change our base map really quick. So we're going to come here to map, select base map, and I'm going to go imagery hybrid because that's going to give me satellite imagery with labels on it. Oh, hold on. I'm going to come here to raster layer and Flicker is another tool you can use, and that's just going to flick the whatever layer you have on and off. You can change how quickly that happens. Oh, that's weird. Why? I'm going to come here to map. I'm going to click explore, and that's going to deselect the swipe feature. I don't know why it doesn't let you just click this again, but you can just come here, click explore, and now you can move around without swiping your imagery layers around. Okay. Next up in your instructions, you have a couple pages going over some just general raster information. So you have, hold on, let me bring this over here. You have a few screenshots of First Dam, which is located in this area here in Logan. That kind of goes over the difference between your half meter LiDAR data and your 5 meter DEM. You have a set of images showing you the difference between your first return LiDAR and your bare earth LiDAR versus your 5 meter DEM. And some more information regarding the difference between your various DEM resolutions, given since it is covering the same extent, the same scale, why it looks different, which is just talking more about resolution and the different technologies we can use. So this next section is going to go over the kind of information that we can get from a raster using our Explore tool. I'm going to go ahead and make sure all my layers are visible and turn on my places of interest. And what we are going to do is come in here to our first area of interest, which is the flagpole next to the stairs down Old Main. I'm going to zoom all the way in here until our cells are really big, so we make sure we're selecting the correct cell. If you weren't sure where to look, you can also come here to the attribute table, and you'll see that our places of interest are labeled. Now we're going to come here to our Explore tool in the top ribbon, and we're going to tell it to look at our visible layers. This is typically set to your topmost layer. So I'm going to select visible layers, and now it should return all of the information on all of the layers that are currently visible. I'm going to select this very cell right here. It's going to do a bunch of identifying, and we'll see now I have the values from my half meter DSM, the hillshade. Oh, that shouldn't be correct, because that is definitely not the darkest value you can have. Interesting. Well, we'll keep an eye on that. This is a good example of to always be critical of your results and your findings, because this is not really the value we would expect from our hillshade. So 0 is the darkest value. As we can see, it doesn't quite look. Oh, well, I can see that being our darkest value. Never mind. Well, and a great example of being critical, because I could have just assumed that that was wrong, or I could turn off my values and check for sure. But we've got all of the different values, world imagery, and if you were to select right on the dot with our Explore tool, you'll also see that we select our places of interest with all these other values selected. You want to keep in mind that so long as you're selecting the correct pixel, you should be getting the same elevations as I am. So if you're getting different numbers, that probably means you aren't zoomed in enough, and so you don't have the exact pixel selected. Now we can see through our different elevations that the elevation for the ground here is roughly 1,453 meters. You'll see our DSM is slightly different. I'll give you a chance to guess why that's slightly different. And if you guessed because the DSM is our first return, and so it's likely getting part of the flagpole in there, then you would be correct. So that's a good thing to note too, because our half meter DEM, this is going to be our bare earth, and our 5 meter DEM, that doesn't take into account canopies and rooftops. Those are going to be the ground versus our first return, which is going to tell us a slightly different elevation. That is the flagpole. So now you should be able to answer question 6. What is the elevation of the pixel that has the Old Main flagpole in it, reading from the 5 meter DEM? And we're going to move on to our next section, where we are going to take a look at our attribute tables for our rasters. Now, if we come here and select, I'm going to go and do our half meter DEM attribute table. I'm not going to do that. Just kidding. It doesn't have one. I shall do our 5 meter DEM table. You'll see that the raster attribute table is not the same kind of table you'll get from a vector attribute table. See, if we select here, we're going to see our ID, our shape, and a title. You might get, if it's a polygon, an area or a length. But here with our with a vector table, you're going to have a row for every record in your data set. For your raster attribute table, what you're going to get is a frequency distribution. It's interesting. I don't understand why it's not giving us a value, but you see we have our row ID and our count. So you see that for every cell that has the row ID of 2, we have 178 cells with the row ID of 2. Should also be getting, interesting. Well, sometimes with your rasters, as you see in your instructions, is you'll also get a value that tells you what the value of that cell is. So, for example, if our value here, let's say, was 40, we'd know that there are 178 cells with the value of 40, and that matches to our ID of 2. So now you should be able to answer question 7. How many cells have the highest cell value? Oh, hold on a second. Okay, I took a look around, and it doesn't look like our attribute table here has a field for the value of those cells, which makes question 7 and question 8 a little bit difficult to answer. So for the time being, how I would approach this is I would come here to our hillshade, which is actually going to help us because we know that the highest value for our hillshade is going to be the highest elevation. So I'm going to just turn these off. I'm going to come here to our hillshade attribute table, come all the way down to the bottom to our highest value. I'm going to select this area, and now we'll see it selected on the map. I'm going to zoom way far in. And now I'm going to make sure my Explore tool is set to visible layers. I'm going to select one of these cells. And I'm going to get that our DEM, that this, it has an elevation of, oh, that's not right. This should be giving us 1540. Instead, it's giving us 1455. Oh, okay. So here's some real life problem solving for you all. Our hillshade value of 254 is covering a range of values, not a set value. So that's something important to recognize. So instead, what we're going to do is we need to find some way to select our highest elevation value of 1540 and identify which row that is in our DEM file, since it's not giving us that range for right now, or that value field that we need. So to do this, what I have figured out is I'm going to come here to our attribute for our DEM, kind of scroll through the row ID, and I'm going to try the first two things that come to mind. So it would be really convenient for me if the uppermost row ID matched the uppermost elevation. So I'm going to try that first. I'm going to select this to have a highlight on the map. We'll see it right here at this edge. And I'm going to use my Explore tool to select one of these pixels. And we're going to see that that matches our DEM 1540. So we got really lucky there. We didn't have to go searching through the entire row ID list. So this is now how you can answer question 7. How many cells have the highest cell value in the extent covered by our 5 meter DEM? Our highest cell value is 1,540. And we can now see that that matches our row ID of 151, and there's 7 cells with that row ID. As for question 8, since we want to know which elevation is most common, what I'm going to do is make sure my selection is clear. When I come to the top here, come to count. This is going to be the count of cells that match this row ID. I'll let you guys give it a try on your own, but because the data you're given is not making it easy for you, you can follow along now. I'm going to sort descending, and I'm going to see, oops, don't know why it swooped me down to the bottom, that the highest number of count is going to be this row right here with over 4,000 cells. I'm going to select these cells so that it glows on the map, and I can see it's row ID 75. I'm going to scroll into the map so I can see each pixel individually. I'm going to pick one that's highlighted, and I'm going to see that our DEM for that cell is 1,464. And if I click a few other cells that are highlighted, all of them have the same elevation of 1,464. So that is going to be your answer to question 8. Now, the next portion of your instructions tells you to open up your attribute table for that 0.5 DSM, which we tried to do earlier. As you can see, there isn't one. If you're curious as to why, our half meter data we can see has fractional values, not whole number values, which means there's going to be essentially an infinite number of values in between each whole number in this data set, which means there's just too many cell possibilities for your cells for ARC to house an attribute table. So you can have one cell for 17,000 or 1730.94, and then one cell for 1730.93, which is just going to take up too much space. So you're not going to have attribute tables for rasters that have data that's not integers. So now you're at a point where you can answer question 9 to explain what the cell value represents in the image on your instruction sheet. So what this cell value here represents. A little bit of a hint for you, if you'd like. This is our hillshade layer value. Remember, our hillshade is just colors to give us some distinction to our DEMs. Your next few questions and the last questions that you have to answer, question 10 through 14. Question 10 is going to ask you, you should be able to answer all of these. Question 10 is just the coordinate system for your half meter digital surface model. So that's going to be in your properties under spatial reference. Question 11 is asking what the units associated with your half meter DSM raster layer are. That's also going to be in your properties here. Got your spatial reference and your extent. It's going to be your friend there. Question 13 is another resolution question for your question 13 is asking about the resolution for this data set, which is also in the properties. Remember, your resolution is the length of each cell in a raster. Question 14 is just another question on coordinate systems, which you should be able to answer no problem. And question 12 is asking you what the elevation is on the surface of the patio outside of Aggie Ice Cream. So if you've never been to Aggie Ice Cream, good thing to do is to come here to our digital surface model, I'm going to open my places of interest table and select our Aggie ice cream, zoom to it, and zoom in way further. We'll see that this is the patio outside Aggie ice cream. So now should be able to select one of these cells and get an elevation. Uh, keep in mind that you're going to want to, I would suggest at the very least, using all three of the elevations you're given to kind of give yourself uh, a, a more accurate number. Remember that the data you're working with isn't perfect and all of them are going to give you a slightly different number. That degree of uncertainty is just something that's always present when working with ArcGIS. So it won't hurt to use all three to inform your answer. And remember to include your units on this answer too. And congratulations, you made it through exercise 7. There's no map or figure to upload this week. You're just answering the questions regarding rasters. So I hope this walkthrough helped, and I wish you luck. Happy mapping!